One of the most common applications of sequential circuits is to design circuits that are called counters. Now, counters are circuits that basically count, right? It starts from zero and counts till a particular number, and then goes back to zero, and then again starts counting up, and then goes back and again starts counting up. Or you could have down counters which do the opposite. You start from some number, let's say 4, and then you have 4, 3, 2, 1, 0, and then you go back to 4. And so that's counting in reverse, right? So let's try to design a very, very simple counter. And let's try to do a, a 2-bit counter. A 2-bit counter will count from where to where. It starts with 0, 0 and counts, it starts from 0 and then counts 1, 2, 3, and then goes back to 0 and then counts 1, 2, 3, and so on and so forth. Okay, so so a 2-bit counter has basically 4 values, and we could write the states like this, right? You start at 0, 0, so that's one of your states, and then you go to 0, 1, that's another state, and then you go to 1, 0, and then you go to 1, 1, right? So your state transitions look like this. And let's say in your circuit you don't have an input. Okay, it doesn't matter what the input is, you don't need any output. All you want is you want the circuit to change states. You want the circuit to go from this state to this state, and then to this state, then here, then back, and keep going this way. Okay, so let's try to design this counter. To design this counter, the first thing that we do is we make a state table. Now, how do we make a state table? What is there in the state table? You have the present state, right? And you have the next state, and uh, so that's all, because you don't have an output, you don't need an output. So let's just do the present state and the next state, okay? And let's just call the states a1 and a0 because the 2 bits of the states. And so then the next state is a1 plus and a0 plus. Okay, so let's try to fill this table up, and it's a fairly straightforward, right? So if you are in 0, 0, your next state becomes 0, 1. If you are in 0, 1, your next state is 1, 0. If you are in 1, 0, your next state is 1, 1. If you are in 1, 1, your next state is 0, 0. Right? Fairly straightforward how you do a state table. Now, what we want to do is you want to use the state table to make a sequential circuit. And for that, you will have to decide which kind of flip-flop you want to use. Let's say we want to use T flip-flops. Let's see in the next video how we are going to use T flip-flops to make this kind of a